You clicked because you saw a headline about a critical vulnerability labeled CVE 2024-YIKES. You want to know if your business or personal data is currently at risk from a specific, newly discovered exploit. The truth is far more complex than a single incident report can convey, and the stakes involve how we fundamentally trust the tools we use every day. By the end of this explanation, you will understand why the specific CVE you are looking for does not exist in official records, and more importantly, you will learn the actual safety protocols you need to implement today to protect against the real, evolving threats in generative AI. Let us start by addressing the elephant in the room. If you have been searching the official Common Vulnerabilities and Exposures database for a record of CVE 2024-YIKES, you will find nothing. The name appears to be a placeholder or a fictional construct rather than a documented security event. This absence is not a relief. It is actually a warning sign about how quickly misinformation spreads in the security ecosystem. When a specific identifier like that appears in headlines, it triggers a panic response in non-technical users who assume a specific patch is needed. But the reality is that the threat landscape for generative AI is not defined by single isolated CVEs. It is defined by systemic flaws in how we interact with these models. Consider the actual technical landscape we are operating in today. While CVE 2024-YIKES is not real, the underlying mechanics that would make such a vulnerability possible are very real. We are seeing documented cases where the very design choices made for developer convenience create massive security gaps. For instance, look at the recent high-severity PHP object injection flaw identified as CVE 2024-14T65 in the WooCommerce Custom Product Tabs plugin. This vulnerability required authenticated access and had a low exploitation probability of only 0.985% according to the exploit prediction scoring system. That specific number tells us something crucial about how attackers operate. They do not always go for the most dramatic, easy-to-exploit targets. They often look for the paths of least resistance where trust boundaries have been blurred. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This brings us to the core of the issue with generative AI. The problem is not just about a specific bug in a piece of software. The problem is about how the AI processes context. When you interact with a generative AI tool, you are not just sending a single prompt. You are building a conversation history that the model uses to understand your intent. The vulnerability we need to worry about, the one that mimics what a CVE 2024-YIKES might look like, is a prompt injection attack that exploits the model's own memory. Here is the thing that most safety guides miss. Standard defenses rely on input filtering. They scan your prompt for bad words or malicious code before the model ever sees it. But an attacker can bypass this by embedding the trigger within the conversation history, not just the current prompt. If you have been chatting with an AI for an hour and the model has accumulated a large context window, an attacker can inject a specific sequence of words earlier in that conversation. When the model processes that history, it executes code or exfiltrates data as if it were a legitimate instruction from you. The safety filters that only scan the final prompt are completely bypassed because the malicious instruction was already processed and accepted as part of the trusted session state. This creates a critical failure mode for both businesses and individuals. For a business, this means that even if you have sanitized user inputs, the internal state of the AI session can be compromised. If your AI agent has automatic tool invocation capabilities, a compromised session could trigger it to access your database, send emails, or modify files. The architectural decision to prioritize developer convenience by allowing automatic tool calls has created the exact vector that attackers are exploiting. For the non-technical user, the implication is a complete shift in mindset. You must adopt a zero-trust approach to every single session. You cannot assume that the AI remembers your previous context in a safe way. You must assume that any shared context could be weaponized to leak credentials or execute system commands. This means that no generative AI session should ever be treated as a persistent, trusted environment. Every time you start a new conversation, you are starting from a blank slate. You must treat the entire interaction history as untrusted input, regardless of how safe the initial prompt seemed. The solution is not better filtering, it is better isolation. Business safety protocols must shift from input filtering to sandboxed execution environments. This means that when an AI tool needs to perform an action, it should not do so directly within your production environment. It should do so in a restricted container where any malicious commands are contained and cannot reach your actual systems. For personal users, this translates to strict session isolation and the immediate clearing of context after every use. Do not rely on the platform's default safety warnings. They are designed to catch the obvious, not the subtle, contextual attacks that leverage the model's training data or tool calling interfaces. This gap between the fear of a specific CVE and the reality of systemic risk is where the real danger lies. If you spend your time looking for a patch for a non-existent vulnerability, you are ignoring the actual vectors of attack. The mitigation strategy requires a reevaluation of trust boundaries in AI agent architectures. We have been treating the AI as a helpful assistant that follows orders. We need to start treating it as a potentially hostile interface that requires strict containment. The career-relevant insight for engineers here is that the mitigation strategy for this class of vulnerabilities highlights that architectural decisions prioritizing developer convenience often create the exact vectors exploited in these scenarios. You cannot build a secure AI system by assuming the user is always good. You must assume the user is the initial attack surface. This means designing systems where the AI cannot execute commands without explicit, human-in-the-loop verification, even if that slows down the workflow. So, the next time you see a headline about a scary new vulnerability, do not panic. Look at the underlying mechanics. Ask yourself if the threat is a specific bug or a fundamental flaw in how we interact with the technology. In the case of CVE-2024-YIKES, the threat is not a specific CVE. The threat is the assumption that our context is safe. By shifting to a zero-trust mindset and demanding sandboxed execution, we can protect our systems without waiting for a patch that may never come. The goal is not to fear the technology, but to understand its limits and design around them. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.